Today we'll be starting off with your topic number 4B, which is alkanes from crude oil. Now, what is the need for fuels and these hydrocarbons? Energy. Everything around you needs energy, electricity, power, produce this machinery, your vehicles, your every industry, they're all working on energy. And due to the rising population, during the rising industrial revolution, the worldwide demand for energy is huge and it is steadily rising. At present, most of this energy comes from burning fossil fuels in the form of coal, crude oil, and natural gas. And most compounds in the crude oil and natural gas are basically alkanes. So in this topic, we will look at the three main processes which are used to convert crude oil into fuels. The first one is
Right.
fraction distillation, second is cracking, and the third one is something new that you will study today, which is reforming. Can you tell me what is fraction distillation?
It's a way to separate mixtures.
Good. On the basis of boiling points, remember IGCSE?
Okay, yeah.
Okay. Crude oil is a complex mixture of compounds, mostly hydrocarbons. The composition of the mixture varies quite a lot depending on which part of the world the crude oil actually comes from. There are types of crude oil. The amount of carbon in the crude oil is different in all of them. And this process is sometimes also called fractionation because it involves converting the crude oil into a small number of fractions. And the number of fractions varies between different refineries, but it is typically six. Fractionation is done in a distillation column. Now there's a whole column over here as well, and you have to first heat it inside a furnace, which turns it into a vapor. अब जब ये gas form में होता है, it is then passed into different columns. Just imagine you have a substance A, and you have to separate it into B, C, D. ठीक है? Now
Mm-hmm.
all these three substances have different boiling points. Substance C has a boiling point of 40, substance B has a boiling point of 60, substance D has a boiling point of 100. You're going to start giving heat. The moment the temperature reaches 40, C is going to leave from A because A is a mixture
Mm-hmm.
of
Boil.
CBD. It's going to boil off and collect it in a column. Then the temperature reaches 60, B is going to fly off, leave A, and leaving behind what? Only D.
Only D.
So there's a temperature gradient in the column, hotter near the bottom, cooler near the top. And as the vapor passes up the column through a series of bubble caps, different fractions condense at different heights. अब यहाँ से it's gonna rise up. यहाँ पे it was liquid, boiling point read turned into a gas, went inside the column, again condensed into a liquid form so we can collect our desired product as well. Near the bottom of the column, the fractions contain larger molecules with longer chains and higher boiling temperatures. And near the top of the column, the fractions contain smaller molecules with shorter chains and lower boiling temperatures. Some of the hydrocarbons in crude oil are also dissolved gases and they rise to the top of the column without condensing. तो bottom वाले पे हैं वहां पे heavy hydrocarbons होंगे because temperature is the highest at the bottom. As you go up the fractionating column, the chain of hydrocarbon would be decreased, less number of carbons because they have a lesser boiling point. They were the ones which boiled first and left the main fraction liquid. Some fractions still contain many different compounds, so they may undergo further fraction distillation separately as well. The second method to produce alkanes is cracking. The word the world has a few uses of longer chain hydrocarbons. For example, decane in this world has no use. Have you ever heard of decane? You haven't. It's a very long chain
No.
hydrocarbon. It's a 10 carbon compound. But if I break it into a short carbon octane, yes, I've heard the name octane. It's a high octane fuel
Yep.
for cars. So longer chain hydrocarbon has no demand in the world. So what is important that you have to crack it. Now this decane can be broken into an 8 carbon compound and a 2 carbon compound ethane. Now ethane obviously has a lot of demand. You can produce
Yep.
ethene, polyethylene bags, plastic, high octane fuels and all of that stuff. Decane was useless. So the demand for shorter chain hydrocarbon is much higher because they are better fuels and can be used to make other substances such as polymers. Unfortunately, there are not enough of these to satisfy the demand. So again, fractional distillation is still the long term and a very common process that's been doing in the industries. Cracking is done
Yep.
by passing the hydrocarbons in the heavier fraction through a heated catalyst. That heated catalyst is zeolite. Now, what is zeolite catalyst that is used in cracking? It's a compound either of an aluminium, you can call it either it's Al2O3 or it contains silicon, SiO2, and oxygen. It's a mixture of all these three compounds. So you can see decane. Decane is cracked into two products, octane and ethene. So by breaking down a large alkane, we produced a small alkane and a small alkene
All
as well. The
right.
hydrogens were total 22. यहाँ पे कितने hydrogens आ गए 18
18
and
plus.
4. तो वो total आपके
Yes.
पास हो गए थे. Reforming is the third method where we produce alkanes. Now, this is something new in A levels. So far, we haven't mentioned one important point about the alkane used as fuels. During the very rapid combustion that occurs in vehicle engines, not all hydrocarbons of the right size burn in the same way. Those with the straight chains burn less efficiently, but those with the branch chains burn differently as well. Now, straight chain ones are more efficient rather than the branched ones. Okay? Branched ones aren't that efficient. So the process
Okay.
reforming is used to convert straight chain alkanes into branch chain alkanes and cyclic hydrocarbons by heating them with caloric. क्योंकि ये बहुत sensitive होते हैं. These are very very sensitive. The straight chain
But the
one, yes,
the purer it is, the better.
the purer it is, the better. The thing is, branched ones have a higher surface area. They can
Yeah.
burn good, whereas these one are less efficient, straight wale. So we are just going to convert pentane into, let's say, cyclopentane, or we can convert heptane in methyl benzene, or this pentane can be converted into a branch as well. Let's say 2 methyl butane, 2 methyl butane भी तो बना सकता हूँ. That four of the carbons lie like this, and on the second carbon I have a methyl. So that is also the same
Right.
formula as pentane, right? The 5 carbon has been converted into 2 methyl butane as well, or I can make it as 2,2 dimethyl propane as well, like this. Main chain is propane, 2,2 dimethyl. This is also pentane, right?
Yeah.
And it can also be converted into a cyclic. So pentane being converted into 2 methyl butane or 2,2 dimethyl propane. This is all reforming. Got it?
Yeah.
Now, how are these alkanes that have been now produced by the three methods, how are they used as fuels? Can you tell me what is the meaning of complete combustion of alkanes?
Can you say it again?
What is the meaning of complete combustion of alkanes?
That complete breakdown of when it is uh, transferred to CO2 and water.
Then what is incomplete combustion?
When you don't turn everything into CO2 and water.
Wrong. Complete combustion always has products of carbon dioxide and water. लेकिन कोई भी चीज
Yeah.
जब incomplete burn होगी, it's gonna produce carbon monoxide and water.
Okay.
Incomplete combustion कब takes place होगी? When you have very less oxygen. But when you already have
Okay.
excess oxygen, complete combustion will take place. And combustion balancing equation is very easy. Remember, whenever you have to balance any hydrocarbon combustion, balance the carbons first, then the hydrogens, and then the oxygens. For example, can you tell me how this balancing is done over here of propane?
Mm-hmm.
Tell me.
I didn't. I didn't get it.
Can you explain me the balancing that has been done in this reaction?
It has
How
been
is this equation balanced? Tell me, explain me.
because it has. But it is balanced. I don't know how to say it.
Good. You have
Because
three
it has
carbons on the
equal
left
amount
and right
of
hand side.
left
Exactly.
side and equal on the right side.
Simple. How would you balance C5H12 pentane plus O2 forms CO2 plus water? Balance this for me. Start. This is the sequence.
Um. Okay. So it's 5 on that side. So add 5 CO2 on that side,
Hmm.
and then hydrogen that 12 on that side, and then you put 6 H2O,
Hmm.
and there's O2. O2 is same. So now there's you need to put so 5, that's 10, and 10 there and 6 there. So that is 16, then 8.
Good job. Simple as that. Incomplete combustion will produce two different products, carbon monoxide and
Oxide,
water.
hydrogen, water.
One of the products of combustion is water, which is not a global problem. But the global problem actually is the carbon dioxide emission that can be environmentally harmful as well. Sometimes the combustion of an alkane is incomplete as well because there is not enough oxygen present or because the combustion is very rapid. All of the hydrogen atoms in an alkane molecule are converted into water, but some of the carbon atoms can form gaseous carbon monoxide or solid carbon as well. So either the product is carbon monoxide, it can be solid carbon as well, and water will still be produced. Now, these products can cause problems. You've studied biology as well before. Carbon monoxide
Yeah,
actually attacks the red blood cells and doesn't let oxygen bind with it as well. So you
yeah.
can see when incomplete combustion forms solid carbon, this can be seen as a black smoke in an air on soot on a burner. Soot is like a black powder that is deposited. We call it soot.
Yeah,
For example, in barbecues, the powder, the black one, that is soot. One example of the equation in which carbon is formed is this. This is an example of incomplete combustion as well. Carbon is being produced. Or if carbon monoxide was produced as well, that would be also incomplete combustion. Carbon monoxide
right.
is a toxic gas that causes the death of many people each year. It acts by preventing the transport of oxygen around the body because red blood cells are responsible for transporting oxygen. But when carbon dioxide is inhaled by a human, the carbon dioxide takes all the space in the red blood cells and there's no space left for the
Yeah,
oxygen to be transported in the blood. It is colorless, odorless, it has no color, no smell, and the people breathe in their lungs without knowing, which is why it's sometimes described as the silent killer. Never turn on your heaters when you sleep. Why do they say this? Because it is incomplete
yeah,
combustion.
because,
Never stay too
yes,
close to the barbecue point. Never turn on the ACs as well and sleep inside a car. That also contains carbon monoxide. Here is an
right.
example of an equation for a reaction in which carbon monoxide is formed. So this is also a reaction of incomplete combustion where carbon monoxide is formed. And where carbon only is formed, this is also incomplete combustion. Complete कौन सी होगी? Which only has carbon dioxide and water. The ultimate
Yeah.
example of incomplete combustion is when the hydrocarbon does not burn at all. A small proportion of the hydrocarbon in a fuel are released into the atmosphere unchanged. They are known as unburned hydrocarbons. Unburned hydrocarbons here that haven't been completely burned. Then we have oxides of sulfur that you have already studied in IGCSE. I'll just quickly review it. Can you tell me what are the harmful effects of these oxides of sulfur and these oxides of nitrogen? You should remember
Like
this.
monoxide.
No, monoxide was different. Oxides of sulfur and oxides of nitrogen. What was their effect and where did these two gases come from? For example, sulfur dioxide, nitrogen dioxide. Remember?
Like the like harmful effects, like I think it
Yes.
burns very easily, and like you said, it reduces oxygen in the tissues,
No,
and
that was carbon monoxide. What about sulfur dioxide and nitrogen dioxide? Where do these gases come from and what are their effects? You have studied it last
uh,
year as well.
they come from incomplete combustion.
No. Where was it being formed in incomplete combustion? What are the products of incomplete combustion? Tell me again.
Oh, carbon monoxide and H2O.
And
Uh,
first
carbon.
carbon as well as, take it. Where is SO2 and NO2 then? SO2 used to be formed through fossil fuels combustion. Nitrogen dioxide due to lightning strikes, volcanic eruptions, SO2 as well. Remember something? And their effect was acid
Mhm.
rain. Now remember?
Yeah.
Some of the molecules in crude oil contain atoms of sulfur as well, and they cannot be removed by fraction distillation. So during the combustion of these fossil fuels, sulfur dioxide gas is also produced. Moreover, from volcanic eruptions, sulfur dioxide gas also comes. And there are two types of sulfur compounds, sulfur dioxide, and if that sulfur dioxide reacts with oxygen, sulfur trioxide. Both of these are very acidic and they can cause acid rain as well. Because when these SO2 and SO3 would react with water, they are going to produce
It will
sulfurous
cause.
acid and sulfuric acid. Got it? दो
which
type
is
of
acid
acid.
rain.
Yes, sulfurous acid, sulfuric acid. Imagine when it's raining, the drop is gonna come down. This is a raindrop coming down, and on the way it reacts with SO2 in the air. What's gonna happen?
Right.
H2SO4 is gonna fall on your skin.
Yeah.
Although very few molecules used as alkane fuel contain atoms of nitrogen, but their combustion occurs at very high temperatures. Why do you think combustion of nitrogen? Combustion of nitrogen means reacting with oxygen to produce NO2. Combustion means what? Burning in oxygen. किसी भी चीज की combustion की बात होगी आप उसको बस ऑक्सीजन के साथ रिएक्ट करा दो. Combustion of nitrogen means N2 plus O2. Combustion of methane means
Right.
CH4 plus O2. Combustion of sulfur means sulfur plus O2. Combustion means reacting with oxygen. So now you tell me, why do you think nitrogen's combustion takes a lot of temperature than all of the other?
Uh, take longer time
Why is it taking a longer time then?
because it takes longer time to burn it completely.
Because nitrogen has a triple bond.
Mhm.
Why does it have a triple bond? Explain the whole covalent bonding.
Because they share three electrons with each other,
Three pairs of electron with each other. Exactly.
three pairs of
So breaking
electrons.
this triple bond is
So,
very tough, and then reacting with oxygen. This
yeah.
formation is
So,
collectively known as oxides of nitrogen. Oxides of nitrogen include nitrogen monoxide as well, nitrogen dioxide as well. And if they react with water as well, they are going to produce acid rain because it's going to produce nitrous acid as well, nitric acid as well. You have to remember all of these formulas. Got it? These are very important. But to solve this problem, we have catalytic converters. Now, what happens in catalytic converters? Cars and other road vehicles are responsible for a lot of air pollution. The widespread use of these catalytic converters fitted to exhaust systems have made pollution less of a problem. And there are different types of catalytic converter, but they all use small quantities of precious metals such as platinum. अब ये catalytic converters क्या करते हैं? These metals are spread tinely over a honeycomb mesh. Honeycomb mesh कुछ इस तरह का होता है which is made up of platinum. It has a very high surface area as well. ये अब मैं क्या बता रहा हूँ? What is a catalytic converter के अंदर क्या हो रहा होता है? One common type is known
okay.
as a three-way catalyst. अब ये catalytic converter दो काम करेगा. The harmful nitrogen dioxide produced in car engines would be converted into N2, and the harmful carbon monoxide produced by the car engine is going to be converted into CO2, and then it is released outside of the cars. You heard every car nowadays has this catalytic converter. Nitrogen dioxide, which
Yeah.
was harmful, is now converted to nitrogen by removing oxygen,
Oxygen, yeah.
and carbon monoxide is converted to carbon dioxide, which is now unharmful by adding oxygen. So there was reduction reaction of nitrogen dioxide and oxidation reaction of carbon monoxide. As the exhaust
Right.
gases from the engine pass through the catalytic converter, several reactions can occur. Examples are the oxidation of carbon monoxide and the oxidation of unburnt hydrocarbon. Look at this. कैसे आपने कार्बन मोनोऑक्साइड के अंदर ऑक्सीजन ऐड करके कार्बन डाइऑक्साइड प्रोड्यूस कर दिए. This was harmful, but CO2 released by the cars is not harmful. Here is another useful reaction as well. Ab nitrogen monoxide was harmful, but the nitrogen that is now being produced is unharmful. So this is the full equation. नाइट्रोजन मोनोऑक्साइड प्लस कार्बन मोनोऑक्साइड. हुआ क्या, ये वाला जो नाइट्रोजन था ये हमने इससे लेके किसको दे दिया? कार्बन मोनोऑक्साइड.
To the, yep.
अब उसके पास कोई ऑक्सीजन नहीं है एंड इट हैज बोथ द ऑक्सीजन. नाउ बोथ ऑफ द
Yeah.
प्रोडक्ट्स आर अनहार्मफुल. So the
Yes.
catalysts currently used are not very good at removing sulfur compounds. The best thing is that you have to remove the sulfur compounds from the fuel before it is being burned. And this is being done in some countries कि बिल्कुल sulfurless fuels produce होने लग जाए. Now many of
So
them are
that's
very,
less would harm the environment less.
बिल्कुल वो burn ही नहीं होंगे फिर अगर आप वो दूसरे different alternatives ले आओगे.
Both nitrogen and carbon dioxide itself, when it burns, comes out of the car. That's not really harmful.
No.
Okay.
Nitrogen and carbon dioxide now the products that the catalytic converter need. Nitrogen, why would nitrogen be harmful? The room you're sitting right now, contains 78% nitrogen around you, doesn't it?
Mm-hmm.
It
Yeah, it
contains some
does.
amount of carbon dioxide as well. It contains 21% oxygen. The most abundant gas right now in your bedroom is 78%. How is it harmful? It's not. But nitrogen monoxide was harmful. Carbon monoxide was harmful. But carbon monoxide
Yeah.
now converted to carbon dioxide isn't harmful. I mean, it is harmful. It is a greenhouse gas, and it's a very big debate. Well, afterwards, carbon dioxide, you can say it's harmful, not to humans, but indirectly to your earth, which is nowadays very common. The term climate change, global warming, it's becoming very common. So long-term carbon dioxide is also not that good, but nitrogen is safe because in your bedroom, remember, now you must be wondering that nitrogen is also present in your room, 78%. Oxygen is
Mm-hmm.
also present in your room, 21%.
Yeah.
And when these two combine, they produce nitrogen dioxide, right? Don't you wonder why are they
Yeah.
not reacting with each other right now? What's the reason?
Because they are all
Because
think
your
they are.
bedroom doesn't have that enough heat or temperature that is required to break the bonds of nitrogen. That is why the only two sources of nitrogen dioxide are lightning strikes.
Volcanoes and
No, that is
volcanoes which
sulfur
has high
dioxide.
enough temperature.
That
Oh
is
yeah,
sulfur
sorry.
dioxide. Lightning strikes, and the second is car engines. These are the only two locations on your planet Earth where the temperature is so high that it can break nitrogen bond and react it with the oxygen. Because right now in your bedroom, in your house as well, nitrogen oxygen both are present, but they can't react with each other because you need a very, very, very high temperature for that. Clear?
Yeah.
So that is where alternative fuels have started to arise. Now, this is a kind of a boring environmental topic, so we're going to go through it. It's mostly theory. There's nothing to teach. It's all remembering. ठीक है? तो ये खुद से read करना है आपने. The need for alternative fuel. Why? Because you've heard from your basic sciences class 8 and 9, you've also studied fossil fuels are harmful, they're going to finish one day, we have to shift to renewable energy sources, for example solar, biofuels, biomass, wind power, hydroelectric power. We've been hearing this from a very long time, right? Because there are serious concerns that one day by the end of 2050, I guess, they are going to be finished. So that is why the need for alternative fuel has been arising. The other concerns are the depletion of natural resource, global warming, climate change. Global warming भी तो हो रही है, आपके पास carbon dioxide emissions बढ़ते जा रहे हैं. And when they
Yeah.
increase, they are going to trap the UV rays and making the earth hotter. Every year temperature is rising. Every year the summers are
Yeah.
getting hotter and hotter. ठीक है, first June used to be the hottest month of the year. Now you have April, May, June, July, August as the hottest months of the year. And recently there have been
Yeah.
attempts to produce new fuels alternative to fossil fuels, for example biofuels. What do you think is the
Yeah.
meaning of biofuels?
Maybe fuels created by more uh,
Living matter,
planet-friendly
plants,
materials.
decomposed plants, wood, centuries से यूज हो रहे हैं. And the terms renewable and non-renewable, what is the difference between these two terms?
Renewable can be replenished by human lifetime. Non-renewable can't.
Exactly. ठीक है, they can be reused, they can't be reused. और
Yeah.
बायोफ्यूल्स क्या होते हैं? जैसे लिविंग मैटर के डिकम्पोजिशन से प्लांट्स, प्लैंक्टन्स, वुड से यूज हो रहा है. Fuels can be considered in terms of their carbon neutrality. What is carbon neutrality? The amount of carbon. जितना ज्यादा कार्बन होगा, the better it burns, the gooder. ठीक है, the better the fuel is, depending on the high amounts
Mm-hmm.
of carbon. कोयले को भी देखें, जो कोल होता है. A good carbon coal is the best that burns. So what does carbon neutral basically means? Carbon neutral is a term used to represent the idea of carbon dioxide neutrality. For example, when a tree grows, it absorbs carbon dioxide from the atmosphere and the carbon atoms become part of the structure of the tree. If the tree is cut down and the wood is burned, when carbon dioxide is formed during its combustion, if the amount of carbon dioxide formed in the combustion is the same as the amount absorbed in the tree's growth, then we say the wood is carbon neutral. क्या मतलब है इसका? Trees क्या करते
That
हैं?
it doesn't produce carbon.
Good. What do trees do? Absorb
They
CO2.
absorb carbon dioxide and release air.
Good. ठीक है. Now, if we cut down trees, why do we say that deforestation is causing global warming? because CO2 is
Because
now building up in the air. There's no one to take it in, right?
yeah,
अब कार्बन न्यूट्रल वुड कौन सा होगा? फॉर एग्जाम्पल इफ अ ट्री इज कट डाउन और हम उसका वुड बर्न करें, मैंने ट्री काटा, यहां से मैंने वुड लिया, अब उनको मैं बर्न कर रहा हूँ, ठीक है? इफ इट इज द सेम अमाउंट, ठीक है, अगर हमने वो बिल्कुल, वी हैव रिपेड द डेट, मैं आपसे कहूँ आई हैव टेकन समथिंग फ्रॉम यू, आई एम रिटर्निंग यू द एग्जैक्ट सेम अमाउंट, आई एम कार्बन न्यूट्रल नाउ, नो हार्म डन टू बोथ, राइट? बोथ गॉट व्हाट दे
yeah,
वांटेड, नो हार्म डन, दिस इज कार्बन न्यूट्रल। मैंने ट्री काटा and then I burned the wood. And if it's the same amount that was absorbed during the tree's growth as well, we call it a carbon neutral wood biofuel. Got it?
yep,
You might imagine that fossil fuels such as those formed from trees could be described as carbon neutral because they too absorb carbon dioxide during the growth and form the same amount of carbon dioxide when they are burned. अब रीजन क्या है कि अगर एक ट्री था, इफ अ ट्री वाज एब्जॉर्बिंग 50, मैं उसको कट डाउन कर दूं, अब उसके वुड जो है वो प्रोड्यूस भी 50 कर रहा है, दिस इज अ न्यूट्रल। दे आर नॉट कंसिडर्ड टू बी कार्बन न्यूट्रल नाउ बिकॉज द कार्बन डाइऑक्साइड वाज एब्जॉर्ब फ्रॉम एटमॉस्फेयर मिलियंस ऑफ ईयर्स अगो, और वो तो अब यहाँ पे बिल्कुल एक्यूमुलेट हुआ था इनसाइड द ट्री। सो ओवरऑल आप देखो कि 100 रह गया एटमॉस्फेयर में, यू हैवंट टेकन इट बेसिकली। If the tree was responsible for absorbing 50, it wasn't absorbed because the tree was cut down, and instead I have burned more 50. तो total क्या हो गया? 100. That is why the amount of
yeah,
carbon dioxide is increasing. अब बायो अल्कोहल्स भी एक चीज है which are also a carbon neutral fuel because they are made from recently grown plants that have absorbed carbon dioxide from the atmosphere. However, this does not recognize the fact that plants have to be harvested, transported to a factory and processed in the factory as well, and the products transported to a point of sale. All of these stages, इसको हार्वेस्ट करो, ग्रो करो, ट्रांसपोर्ट करो, मार्केट में रखो,
hmm,
सेल करो, ये सारी स्टेजेस में एनर्जी यूज नहीं हो रही। मैं pehले
yeah.
एनर्जी लगाई है ट्रीज को
Cars
काटने
using the
में, एग्जैक्टली।
trucks using engines and stuff.
बिल्कुल, अब मैं ट्रक में डाल रहा हूँ, आई एम यूजिंग मैन पावर नीड्स फूड, द ट्रक बीइंग लोडेड नीड्स पेट्रोल, पेट्रोल भी कहाँ से आएगा? इधर से ही आएगा। यू आर ट्रांसपोर्टिंग समथिंग, यू आर ट्रांसपोर्टिंग पेट्रोल यूजिंग पेट्रोल, तो एनर्जी तो हर स्टेज पे लग रही है। व्हेन यू हैव टू सेल इट, यू आर रनिंग अ शॉप, द शॉप इज रनिंग ऑन इलेक्ट्रिसिटी, इलेक्ट्रिसिटी इज बीइंग यूज्ड बाय पेट्रोल। So it's all a vicious cycle basically. It still becomes a vicious cycle that at every stage, at every point, kahin na kahin energy is always being used. Overall, the use of bioalcohols involves forming more carbon dioxide than it is absorbed. So, but still they are closer to being carbon neutral a bit. Bioethanol,
Right.
commonest bioalcohol. Remember, bioethanol और अल्कोहल थे वो डिफरेंट कंपाउंड्स नहीं है। भी इट इज बेसिकली एथेनॉल ही है, जैसे C2H5OH इसका फॉर्मूला है। द टर्म बायो
Mm-hmm.
नेम ओनली रेफर्स टू द मेथड ऑफ प्रोडक्शन, कि हम इसको फर्मेंटेशन शुगर से करते हैं, रिमेंबर एनारोबिक रेस्पिरेशन,
Yeah,
शुगर
I remember.
फर्मेंटेशन करोगे तो ये होगा, यीस्ट की हेल्प से होता है, एंड देन दे प्रोड्यूस दिस ethanol which can be used to produce energy by respiration. It is now possible
Yeah,
to use a wide range of plants and also plant waste to produce ethanol. The upper limit to the amount of ethanol that can be obtained from a given amount of starting material is increasing, and it is much higher than in traditional fermentation. In the United States, imagine corn is the main source of ethanol that is used in cars. क्योंकि plants में anaerobic respiration कैसे होती है? Fermentation.
yeah.
ह्यूमंस में एनारोबिक रेस्पिरेशन इज डिफरेंट, वो लैक्टिक एसिड वाली होती है। एरोबिक दोनों में
Mm-hmm.
सेम है, बट एनारोबिक इज डिफरेंट इन बोथ। प्लांट्स में फर्मेंटेशन होगी उस सुक्रोज की, उस ग्लूकोज की। तो यहाँ पे इमेजिन कार, यूनाइटेड स्टेट्स में कॉर्न प्लांट्स आर अ मेन यूज ऑफ एथेनॉल, जो कॉर्न प्लांट्स प्रोड्यूस कर रहे हैं एथेनॉल, वो यूज हो रहा है एनर्जी में। सो इफ वी नाउ
Yeah,
कंपेयर दीज फ्यूल्स, द चॉइस ऑफ ऑल्टरनेटिव, वैसे ये क्या लिखा हुआ है? एग्जाम क्वेश्चंस आस्किंग यू टू कंपेयर फॉसिल फ्यूल यूजुअली कैरी 4 or more marks, a very important theory question. Now this one doesn't involve any calculations, nothing, कुछ भी, ये तो सिर्फ written वाला है। written है, there is no structures, compounds, name, formulas, it's all written। तो remember इसका 4 mark तक का भी क्वेश्चन आ सकता है। comparing and imagine, look, avoid poorly presented and poorly structured answers। पहले हमेशा अपने माइंड में प्लान करो जब 4 मार्क का सवाल आता है कि फर्स्ट आई विल
mm-hmm.
एक्सप्लेन बायोफ्यूल्स, देन आई विल कम टू बायोएथेनॉल, देन आई विल कम टू बायोअल्कोहल। मेक अ माइंड मैप इन योर माइंड और यूज अ पेंसिल टू राइट डाउन पॉइंट्स फर्स्ट, देन राइट अ प्रॉपर वेल स्ट्रक्चर्ड आंसर। देखो यहाँ पे वो बता रहे हैं एग्जाम एंड में। So the choice of alternative fuels is continually changing as new sources of starting material and new processing methods are being investigated. There are many factors to consider in any comparison, but for biofuels such as bioethanol, these include the following: कि land कितना यूज हो रहा है, कितनी yield, कितना product produce हो रहा है, how much energy or cost is required in the manufacture and transport, is it even carbon neutral or not. ये सारी हमें चीजें factors mind में रखनी पड़ेगी when we want to compare. I can compare all types of fuel on the basis of land use, the product produced, manufacture and transport, and carbon neutrality. So this is the four criteria. This is a 4 point
Right.
criteria that is going to help me. Now, the one which is best in all these four uses the least land, produces most product, least energy is transport, and the most carbon neutral.
Most
The best.
common, yeah.
For a long time, hydrogen has been considered an ideal alternative fuel as well, but it is not a biofuel. Biofuel नहीं है. Cars में use हो सकता है. Natural gas में, petrol में, it can be used
But how
in
would you harvest get hydrogen into the car? Would it last long?
it. हाइड्रोजन कहाँ से आते हैं वो हम वाटर से लेते हैं. देयर इज अ होल बैक एंड स्टोरी टू दैट कि हाउ इज इट ऑब्टेन्ड फ्रॉम वाटर.
But doesn't that also take a lot of energy to
It does.
create?
That is why we are saying that we did consider it as an ideal alternative, but it's not. It's not biofuel पहली बात तो. ठीक है, ये हाइड्रोजन फ्यूल सेल और बर्निंग हाइड्रोजन है तो सेम चीज ही. नो कार्बन डाइऑक्साइड प्रोड्यूस, दिस इज अ गुड थिंग. सो नो इंक्रीज इन ग्रीन हाउस इफेक्ट. लेकिन मसला क्या था इसको प्रोड्यूस करना. मेकिंग अ हाइड्रोजन फ्यूल सेल रिक्वायर्स अ लॉट ऑफ एनर्जी. तो जो आपको उसने प्रोडक्ट देना है वो वैसे ही आपके पास बैलेंस आउट हो जाता है. However, nearly
Yeah.
all the hydrogen present in the water molecules in the ocean, obtaining hydrogen gas from water is not difficult, but it requires energy. अब आपको अगर हाइड्रोजन फ्यूल सेल इज वेरी गुड, the best cell in the world, but making it is the worst. Got it? Take it as this.
Yeah.
It could come from electricity, but how is electricity generated? आप ये देखो कि सेल बेस्ट है. ठीक है, वाटर भी बहुत है अर्थ पे, हवा भी बहुत है. वाटर इज नेवर फिनिशिंग, यू हैव अ लॉट ऑफ वाटर, बट द प्रोडक्शन रिक्वायर्स एनर्जी. कहाँ से आएगी एनर्जी? इलेक्ट्रिसिटी. इलेक्ट्रिसिटी कहाँ से आती है? बर्निंग फॉल. तो आप वो
Yeah,
बैलेंस आउट कर
exactly.
रहे हो. एग्जैक्टली. इफ द इलेक्ट्रिसिटी कम्स फ्रॉम द पावर स्टेशन दैट बर्न फ्यूल, तो फायदा क्या हुआ? आप वो सेल बनाने के लिए भी तो एक फ्यूल को बर्न कर रहे हो. देन डोंट इवन बॉदर मेकिंग दिस सेल. अगर ये फ्यूल बर्न होना ही होना है, देन लेट इट बी एज इट इज. इफ देर इज नो अदर वे अराउंड अदर देन बर्निंग फ्यूल, देन व्हाई मेक दिस हाइड्रोजन सेल्स. अनदर मेजर प्रॉब्लम, जो दूसरा प्रॉब्लम था वो क्या था? स्टोरेज. The gas has a very low density. It has the lowest MR in the periodic table, right? This means a very strong container and therefore a very heavy हो, वरना ये तो evaporate हो जाएगी. It has a boiling point of 253 degrees Celsius as well, and it should always be very cold. क्यों? कितना टेम्परेचर होना चाहिए इसका? इट शुड बी लाइक -500 तक इसको स्टोर करो, क्योंकि अगर ये -253 भी हुआ, इट्स गना बॉयल. गॉट इट?
Right.
Battery technology has improved greatly in recent years, and the range of battery powered cars is continually increasing. Many scientists believe that this is a more practical alternative than using hydrogen as a fuel. तो अब storage, अगर बैटरी आपकी अच्छी है, अगर you are sure that you have very good storage battery, फिर ये hydrogen fuels yes successful हो सकते हैं. So you can also compare these fossil fuels with biofuels. Here is one example. Now, can you read this out? Natural gas or biodiesel and ethanol. First, tell me about their land use.
A lot of land needed, which in some cases might replace land used to grow food.
ये हो गया biodiesel और bioethanol का. And compare it with natural gas.
Where there's no land needed, it comes from underground sources.
So what is good?
Natural gas.
Next,
Yield low but gradually increasing. Yield very high.
what is better?
Biodiesel and bioethanol.
ठीक है, good है. Next,
Manufacturing transport, no exploration or drilling costs, substantial cost in growing, processing, and transport. Exploration and drilling costs very high, processing costs low, transport costs low, but costs low by pipeline. I mean, this one depends where you are and where
exactly.
you get fuel.
उधर exploration नहीं है, transport है. इधर exploration है, transport
Yeah,
नहीं है. तो it's like balanced. Then next,
yeah. Carbon neutrality, much closer to being carbon neutral, definitely not carbon neutral. Then it's biodiesel and bioethanol.
Hmm. So biodiesel, bioethanol. Lekin again, this is
Yeah.
why this is the dilemma that the world right now is stuck in, and they're not wrong being stuck in this dilemma because we both are
Mm-hmm.
right now as well. That which one is better, and that is all for today.